God. Oh my God, dude.
Of course it would.
What is wrong with people saying this? It's so annoying. Accelerometers are just set to not pick up gravity, so you can test for actual like changes in acceleration to things. Because everything's always being pulled by gravity. So why would you have it not notice gravity? How would you test for anything that you're trying to actually test for?
What did you just say?
Measure a force. They just sit there. They have a spring and a weight, and they effectively measure the deflection of the spring based on the force that.
Yeah, and it's calibrated to not measure gravity, so that you don't.
That's not true.
Have it measuring.
That's not true. There's no calibration in an
Yes, it is, dude.
around gravity.
Inside the MEMS chip,
zeroed out,
is proprietary. It's proprietary, so you don't really know what's in there. They say it's capacitive chips.
There's a couple ways to do it, probably.
Oh,
you
can easily
make an accelerometer yourself with the spring.
Exactly.
With a bunch of springs, rubber bands, water, anything. You can do this and prove that incorrect, man.
Yeah, but it won't show anything at rest if you're doing it like mechanically.
It will.
Like the original
size. That
shows a force from underneath.
It will. That's the issue. Like if you
you know what a seismograph is?
If you do the accelerometer with just a spring and a mass, then once you align it vertically, the mass is going
a seismograph, and it doesn't read anything at rest.
Okay, but that's not related to measuring.
They only read readings.
Can you not interrupt me
after 1949?
Can you not interrupt me? Okay. If you put a mass suspended by a spring, let's say horizontally. If you accelerate that horizontally, the mass is going to be displaced.
That's my point.
Can you not interrupt me? Can you
I don't know what your point is. You interrupted me.
I didn't. Okay, thank you. Yeah. So if you do that horizontally and you accelerate it horizontally, the mass is going to displace horizontally, and you can do those in 3 axes. If you do that on all 3 axes, there's only on one axis where the mass is always going to be displaced. That's on the vertical, and it's going to be displaced downwards. So that's the accelerometer detecting gravity. You can't not detect gravity with an accelerometer. If you try to compensate for that, making like a...
You're saying an accelerometer detects gravity when they say it detects normal force, what's called normal force.
No, they don't detect normal force.
You don't?
No.
You sure about
Look,
that?
I'm really sorry. I had a phone call. I didn't mean to leave in the middle of that conversation.
No worries.
It detects acceleration.
Yeah, proper acceleration.
I didn't mean to offend you, Bacon.
No problem.
But anyway, what I was saying is, before the accelerometer, it was seismographs, and that if they were all mechanical, they didn't measure anything at rest. That never happened until 1949.
Don't seismic graphs just detect like oscillation? If you accelerate constantly, then what would you detect?
What?
Don't size
at rest. At rest, it doesn't detect anything. It only detects things if the Earth moves.
I know.
Seismograph.
Yeah, because it moves in opposite directions all the time. Like it oscillates, right? It goes back and forth. That's a changing acceleration. Gravity is a constant acceleration.
At rest, it doesn't detect anything if nothing's happening.
I know.
It wasn't until the 40s when they said, "Oh yeah, it's detecting."
Why would it detect anything?
Free fall speed at rest. What?
Why would it detect anything?
Well, that's your argument, right? Accelerometers measure free fall at rest, and that proves gravity.
It doesn't measure free fall at rest. If you put it at rest, it measures 9.8 meters per second squared.
And what is that? Free fall speed?
No, if you drop an accelerometer, free fall measures 0. That's free fall.
So you're saying that accelerometers don't measure anything?
At rest, they measure 9.8 meters per second squared. At free fall, they measure 0.
And that's free fall speed, right?
That would be the acceleration at free fall.
Yeah, but that completely makes sense. Like, no matter what the effect, whatever we want to call gravity is, whatever it is, whatever that happens, outside of that, if you have, like, it's just dude, like a simple sense of it, if you're standing on a scale, it's going to measure your weight. That's essentially because the sensors, like there's weight on one versus the other, so it presses on it when the accelerometer is at rest. So we know that like if you and I were both standing on scales to get, you're on your scale, I'm on mine, we're both measuring our weight. But if we both jump off a cliff together and now we're free falling, we're not moving in relation to each other. So that's like the two sensors in the accelerometer they're both falling together. They're free falling together. It doesn't mean that there's nothing acting on them. And that's the twist that they do in the model where they try to say, well, there's nothing acting on them and now relativity and all this. It doesn't mean nothing. Whatever the thing of falling is, downity, it's happening when the accelerometer is falling.
I
It's
agree.
accelerating at 9.8 meters per second by fact, like you can measure that. But when it's
Yeah.
at rest, there's not moving at all, but there is something on it, on the two, what you call weight, just like standing on a scale.
That's the Newtonian interpretation. That's right. That there's no issue with that. If you're saying that during free fall there is no acceleration, then that's the general relativity interpretation. In Newtonian,
Yeah,
there
but-
is acceleration, but it's not measurable when you're in free fall.
Yeah, but it's still only a force in that sense that you said before of a pseudo force, which I agree with you. That's still a force, but specifically, that is what that force that's causing it.
I didn't get that. Could you say that again?
In
Kosho?
Newtonian, it's a force. In Einsteinian, it's a pseudo force.
That's right. Oh, someone get it?
No, so that steel manning. I don't believe it.
Bacon, like the upward Earth idea kind of uses the accelerometer free falling as if it's not in motion at all, and therefore the Earth is rising up under it, and it's just at rest.
Oh, the opposite. That's the idea that it is in motion. It's accelerating upwards. That's the idea of general relativity. Yeah, those are different. Like you can interpret from the lenses of general relativity and say that the ground is accelerating upwards, and when it's in free fall, then it's inertial. Or you can go with Newton and say when it's free falling, it's accelerating downwards, and when it's at rest, when it's on the surface, it's at rest. Those are two like the consequences are exactly the same.
We need Jeremy's tree example.
No, I got you. Yeah, that's sort of the globe Earth version of the Earth rising up. I was more talking about like the planar upward rising and the accelerometer discussion there, like a planar that's a planar Earth that's rising up. But yeah, you're talking about the globe version of the kind of Earth coming towards you, which, yeah, the relativity one. That whole.
Oh, you're talking about the flat Earth accelerating upwards?
Yeah, I was actually more referencing that one, but you were referencing the globe version. But yeah.
Yeah, that's a
The
valid.
measurements are all the same.
Yeah,
I'm
don't
just
think
saying,
that.
before they were called
God.
accelerometers, they were called seismographs, and they were mechanical. And it wasn't
They're
until the
measured different
1940s.
things.
Dude, do you have to always interrupt me? I'll let you fucking talk.
Yeah, let's let everyone finish their point.
The point is, before they were called accelerometers, they were seismographs. They were mechanical, and they didn't detect anything at rest. But in the 1940s, when they made them electrical and shit, now they detect shit at rest. It has to do with the shape of the capacitive plates, which we don't know what's exactly in the memes chip because it's proprietary. And then
Bro, you're
in the
so
case
Right.
of
Can I just add, adding an
accelerometer-
electrical globe? All right, I thought you were done. Sorry. Go ahead.
Oh, fuck, nah, forget it, dude.
Bro, I said.
Yeah.
I thought you were
Yeah,
done.
seismic
You stopped
graphs.
talking.
Yeah, seismic graphs are not the
Go
same
ahead,
thing as
Deacon.
accelerometers. They're not supposed to measure the same thing. They don't work the same way. So it doesn't make sense to say that.
They're the forerunners to accelerometers, dude. What the fuck are you talking about? The
They
same thing
measure
happened-
oscillations. They measure
Talking about-
waves. Gravity is not a wave, it's not an oscillation. It's
They're
a
not-
constant acceleration.
accelerometers measuring waves? You sure about
No,
that?
seismic graphs. If I said accelerometers, I misspoke. Seismic graphs, they measure waves. They measure oscillations. If you're not oscillating, if you have a constant acceleration, you wouldn't measure a thing. It doesn't make sense to. It doesn't make sense to treat. It doesn't make
They're
sense
on
to say.
springs.
Yeah, they
Now
have.
you're cutting him, bro.
I'm just saying
It
they're measuring
doesn't-
the same things. Look into it. Memes.
They don't
and
measure
what a
the same
seismograph-
thing.
A memes chip. It has springs. They both have springs. They're measuring mass.
Yeah, seismic graphs measures waves. They measure oscillations. Gravity is a constant acceleration. accelerometer can measure constant acceleration. A seismic graph can't. Those are different things. It doesn't make sense to treat them as if they're trying to measure the same thing. As if seismic graphs used to be accelerometers or the other way
Hold
around.
on. Accelerometers aren't used in seismographs?
I didn't say that.
Well, I mean,
Same
Bacon,
thing,
like
dude.
basically, I mean, they like seismometers are sensitive accelerometers.
Okay.
So you're not talking about seismometers?
They zero it out, right? So in a seismograph, you've got a mass and a spring recording displacement. So when the seismic wave comes through, it effectively shakes the machine, and the reference mass is suspended on a spring, and the machine moves and the mass doesn't. So you get this motion, which is just like an accelerometer. And I think they have them in two axes to measure the different components of the seismic wave. But
also they have different stations, you know? That's how they can find an epicenter and shit.
He's saying Bacon.
The
He's not
reason they
wrong
don't
about
show
the
anything
connection.
about
He's not wrong about the seismographs and seismometers have some overlap with accelerometers.
Yeah, I'm not saying there is no overlap. I'm saying they are not the same thing. If you pick a seismic graph and accelerate at a constant acceleration, it's not gonna get any oscillation. That's what's measured. It's not gonna be. It's not shaking. Just at a constant acceleration, it's not gonna measure anything.
Yeah,
I
it's
got
trying
you.
to
Go
measure
ahead.
the changes in acceleration. So if you imagine the accelerometer is just the seismograph is just a steel bar with a weight on the end with a pen on it, that when it's just sitting there, it's only influenced by gravity, right? So it'll have a 0 point that is just caused by gravity. And if you have an electronic MEMS accelerometer, same deal. If it just sits there, it'll show a fixed reading that is caused by gravity. But then if you shake it up and down, the changes in acceleration are what is recorded. And both the MEMS accelerometer and the seismograph will exhibit similar behavior there, that they will show a change in the acceleration that they're experiencing.
Ether displacement.
Potato.
Yeah, my whole point is nothing is happening at rest, but they're trying to say something is being measured at rest. That's all.
Yeah, that's what an accelerometer measures. If you put it at a table, it the reason your phone knows where down is, regardless on how you orient it, is because of the accelerometer.
Yeah,
No, it
that's
doesn't. You have it
like
tilted
extra
sideways.
information. Yeah, I already know that. So what does that have to do with anything?
So it measures the weight at rest. It measures it at rest. You're saying nothing is being measured at rest. That's not true.
When it's at rest, it's programmed or however it's programmed to read that reading, but it's nothing is actually happening. That's my point. Because before, when it was mechanical, nothing happens. But when they made it electronic, and they it has to do with the shape of the components, the capacitive plates, the frequency of the piezoelectric crystal.
Well, if that was true, if it was true that the accelerometer doesn't measure an upward acceleration and rest, that is just programmed to say that it does, it wouldn't know where that direction is. Because it wouldn't be measuring anything. You wouldn't know where to point at.
If you move an accelerometer to the side, does it measure anything?
If it was at rest and you move it, then you accelerated it, so it will measure it.
Doesn't measure shit if you move it to the side.
As you're moving, you're accelerating, so you would capture that as you capture that acceleration. You would measure that acceleration. What are you talking about?
Yeah, the mechanics of them are designed to only measure acceleration in a particular direction, though, which is why you have 3 of them in your phone, one for each axis. And they only measure the acceleration component along that axis. So if you have your phone facing down, the accelerometer that is through the plane of the screen, perpendicular to the plane of the screen, will show 9.8. If you accelerate your phone sideways, you'll get the sideways accelerometers being triggered. If you accelerate your phone forwards and backwards along the length of the screen, the other accelerometer will measure something. If you accelerate it up and down, you'll get...
I agree with all that. That's what the circuit was designed to do.
Yeah, but you can build this yourself, right? You can create an accelerometer with just a steel bar and a weight on the end, and you'll get the same result. So if you rotate the steel bar around, the axis of the downwards force will move as you rotate it, exactly like the MEMS accelerometer does.
It's measuring mass. Yeah, I get it.
Yeah. So there's nothing magic in a MEMS accelerometer. It works the same as any other mechanical
When it's sitting
accelerometer you
still,
want
it's
automatic.
not measuring shit because it's just sitting still.
But you just disagreed with that right now. He just described how it is measuring an upward acceleration because of the weight of the mass, and you just said yes, you know that how it works, and now you're saying the opposite, that it doesn't measure
Well,
anything. You just
yeah, well,
agreed.
some are. He literally, but he also said some are calibrated not to measure that.
No, I mean you can try to compensate the 9.8 meters per second square. I don't know how, because you have to know if that's in what direction
If
that
you
is.
look into the history of accelerometers, before 1949, they didn't measure shit at rest.
Yeah,
You could look that up.
history is relevant. You can make a simple acceleration like easily on your house.
Yeah, but
with
dude,
simple tools.
well, I'm going to say it again. I know I kind of said it before, but I just posted the image in the chat, the animation. So, I mean, just, you have the fixed plates and the springs and the mass in between. Now, if you place that, like where the right side of the red part there on that animation, the right side, if that was on the ground, and then over on the left where it says springs, that was vertical up, then obviously that red thing, because it's not fixed, it's springy, is going to have what we call weight, like standing on a scale, and it's going to press on those green plates a little bit. Now,
Exactly.
whatever downity is, gravity, etc. Yes, but that doesn't mean that it's accelerating though. It just means
Right,
that
but
there's weight on it against fixed plates, like a fixed Earth standing on a fixed scale. But if you then jolt that thing around and start going up, down, yeah, sure, it's going to then start measuring acceleration. So this is a device that can measure acceleration when you move it around. But when it's at rest, just because it's picking something up doesn't mean that it's measuring acceleration. You see
that's
what I'm saying?
exactly
Like,
what we're talking about. That's exactly what we're
yeah,
talking
you
about.
agree. I think
It-
you agree because I'm pretty. You like when I've talked to you about this. You
yeah,
agree with that?
yeah. In the Newtonian explanation, that's exactly what's happening. Like we can't distinguish between if it's the weight of the mass or if it's accelerating upwards. Those things measure the same. The accelerometer doesn't know how much of the component is gravity and in what direction that is. It only knows the net effect on those masses. Yeah, so the accelerometer can't just eliminate gravity. What it does is it simply tells you the net displacement on the bars and works that out as an acceleration. It could be that that's just the weight of the mass. It could be that it's accelerating upwards. The accelerometer doesn't know, but it will be measuring something. It might be that it's measuring the mass of the bar, or it might be measuring acceleration. It doesn't know, but it will be measuring something. That's what we're trying to tell calm max down, whatever that's pronounced.
It's just calm down. Well, okay, but so, right, but he was saying that it doesn't mean it's in motion, and you were saying it's picking it up, but so maybe he thought you meant that it was in motion. I mean, are you claiming this is
Oh.
measuring acceleration when it's at rest?
No. I'm saying no. Yeah, I'm saying it measures something. If the accelerometer only tells you, okay, I'm measuring acceleration in this direction. It might be wrong. It might be that that's just weight because that's how Newtonian works. But it is going to be measuring something. That's what I was telling him, because he was saying,
Alright,
well, if it's at rest, it doesn't measure anything. That's not true. It measures, but that's on an Newtonian world, it's picking up the mass, the weight of the masses.
Yeah, but they also
This is
calibrate them. They also calibrate them though, like to basically cancel out the 9.8, to where then when it's at rest, your phone knows it's at rest, kind of thing. Even though it is technically the MEMS is picking it up.
I'm not sure you can do that. Like, what happens if then I accelerate it downwards by twice 9.8, so 19.6 meters per second squared? Is it going to think it's just upside down and it's going to give me zero again, or is it going to pick up the 9.8 meters per second squared in the opposite direction now? I don't know. It doesn't sound like it's going to give me zero.
Well, I think that's kind of more in the software though. Is kind of what I'm referencing. Because yeah, the actual circuitry is going to give the result. I mean, in the MEMS ones, like they use it's like it's like a conductive electrical charge. It's not necessarily
They use
springs.
capacitive plates, is what they say, but they don't
Yeah.
say what they exactly are because it's proprietary.
Yeah, they're like chips basically. Like it's
I mean-
conductive. It's an electrical process, not like actually springs in there with a physical thing.
But there's nothing special about the electrical process that you can replicate the behavior of an accelerometer with physical things that you can get your hands on. So, if you had got a box,
you're putting voltage in and getting voltage out, the capacitive plate's shape makes a difference.
Yeah. That's the sensitivity and precision of the thing, right? That's what all that stuff's about. But you can build an accelerometer, a mechanical accelerometer, that will exhibit exactly the same behavior as the MEMS ones, right? That if you have a steel bar with a load on
read
it,
anything at rest.
no, it will. You'll measure a difference. So if you take the MEMS accelerometer, right, just a single axis one, have it facing up and down, you'll get 9.8. And if you turn it upside down, you get 9.8 in the other direction, right? You can replicate that with a steel bar with a weight. And if you say you zero it
I
out,
don't know if that's true or not. I've never seen
no, it
anyone
is.
do that.
You can do this yourself. You can,
Show me a
if you've got a flexible rod.
Show me some
So
proof.
if you take that accelerometer in one orientation and it's showing 9.8, you zero it and turn it over, you'll get
Show me that, dude. I'm just saying, like, I've never seen that done. There's no video on that.
I've
That's
got a
kinda
few
what I was
videos on
saying,
my
Bacon.
channel of it.
Like, to me, it sounds like it's taking the weight of the object, and then it's basically telling you how much it would be accelerating if the pressure being put on that object or being put on that sensor or whatever it is to, like, get the thing. It's probably just converting that pressure into what do you call it?
The main
An
sensor is not
acceleration.
totally mechanical. It has
That's
to do
right.
with
That's the Newtonian interpretation. That's right. That's exactly what we're telling. So like if you make an accelerometer only on the horizontal axis, so you put a marble suspended by two strings horizontally. Let's say you accelerate the thing sideways by 9.8 meters per second square. The marble is going to be displaced between the springs. That displacement is going to be the exact same if you simply orient it vertically. It's going to displace the same amount. It matches the 9.8 meters per second square if you do that horizontally. So from the point of view of the marble and the springs, it doesn't know the difference between I'm just sitting vertically or I am horizontally accelerating 9.8 meters per second square. It doesn't know the difference.
Right.
And if you drop it, then it's going to sit in the middle between the strings as it's falling.
Yeah, and that's the whole thing, right? That the accelerometer cannot distinguish between its own weight on the spring and an acceleration. They all appear the same.
Yeah, that's what I was saying. In the software, they do things to sort of zero it, as you said. Like, so your phone, like in a video game, it knows how much you actually moved it down or up or left or right, in the actual software. But because they have to, they still want to get accuracy. They don't want it to just be like if you moved your phone up at 9.8, it's the phone is going to register you're moving up. It's not going to register that you're just because you're canceling out the 9.8 that would be on it. It doesn't say your phone's not a motion. It knows it is, which means it has to cancel out the original 9.8
It'll
at rest.
add to the 9.8. If you accelerate it up, it'll add to the 9.8.
Yeah.
Right.
They
Yeah,
normally,
yeah. You're right. I said that slightly wrong. But yeah. So yeah, well, isn't it also? I don't know this part of it, but I know that when you have to calibrate an accelerometer on your phone, you know how you have to do the figure eight. If you guys had to do that, different devices and things, and you have to calibrate your accelerometer, and it tells you, it's like in 3 seconds, 3, 2, 1, 0. You're supposed to put your literally make your phone go in a big figure eight, and then that I don't know. Maybe someone knows why it has to do that.
that's the compass to calibrate the compass.
Oh, by thinking of the compass. Well, it uses the
So if you swing a compass through the electronic compass through all three axes, you can work out where the minimum and maximum are and determine the correct orientation of the compass.
Yeah, but that's using the accelerometer to get that, right? It's using the. I was thinking of the accelerometer in that, but you're right. It's not. It's now that I think about it, you're right. It is to calibrate the compass, but it's doing something.
The accelerometer would be involved in determining the orientation. So the accelerometer would be able to tell that your phone is flipped over, for example, and that would be matched up with the compass, so that when the phone says, "Yep, we've done a 180 through the accelerometer," the compass has also done a 180, and we can combine the two together and work out where the compass is actually facing.
Well, is that like a form of zeroing then when you do the figure eight?
Kind of, yeah.
Yeah.
And a lot of phones have another thing they call it an absolute orientation sensor, and it uses the accelerometers, the gyros, and the magnetic sensors in the phone to effectively eliminate gravity or to understand where gravity is all the time, like a miniature inertial navigation system. So it needs to work out where down is, and it does that by going through that calibration process, and then as your phone moves around, it's able to work out what is caused by gravity, what's caused by motion, and keep a good reference as to what down is, regardless of what else is going on.
Yeah. Well, Jason, since you're here, what are your thoughts on this? Like in terms of any with all this, in terms of if there's any motion with the Earth and the accelerometers and
Yeah, it just comes down to, with me, like proper acceleration, in my opinion, requires a force. It's real acceleration requires a force. Coordinate acceleration would be like what's caused by a pseudo force, which is basically the reference frame. If the reference frame is what's really accelerating, then objects inside the reference frame would be experiencing a pseudo force. And so, how do you know the difference between which one is proper accelerating and coordinate accelerating? Would be an accelerometer. You could say that the accelerometer on the ground is measuring a proper acceleration upward, or that everything is being accelerated down equally, so that there's no difference whenever it's in free fall. I mean, you can interpret it either way. To me, it makes more sense that the acceleration is upward than a force that cannot be replicated in any way whatsoever to accelerate all forms, states of matter equally, no matter the mass or quantity. Everything accelerating down exactly equally. That kind of force, yeah, it's not replicable, and I don't see it. It makes more sense to me that everything is just accelerating up. The ground's accelerating up, and everything in the reference frame, is going to the ground because of the force up.
So you're saying the ground is accelerating at 9.8?
Yeah.
So then I know there's always that question people ask, like, this is like the equivalent, like the first thing whenever someone mentions the dual pole, they're like Pac-Man. They have to say Pac-Man because of the east-west circumnavigation. The equivalent of this is with the upward at 9.8. It's like, so are we going at quantum light speed, like ludicrous speed right now? If we're always
Probably like
accelerating up at
plaid
9.8.
speed or something. Yeah, like plaid
Yeah.
speed probably. Yeah, but relation to what though? And why is there a speed limit?
So your answer is like if it is, from the accelerating up idea that it could be going at
Yeah, it could.
multiple times the speed of light or whatever. Like
So in relation to something outside of the reference frame that we could never see or get to or reference to, maybe, probably.
yeah,
All we can measure inside the reference frame would be the force underneath our feet. The speed relative to anything outside of the reference frame, we have no idea. And there's nothing to me that can dictate why we wouldn't be able to go, why there would be a speed limit. If all we can do is experience what we're experiencing inside this reference frame.
it makes me think of like teleology, like a goal, like goal oriented, or like a goal, like because if it was accelerating like that, it seemed like what, like from that idea, it's like we're really moving towards something. Like where are we going, kind of thing, at that rate.
Right.
But I guess it's just my like human conception of it. Because like what's beyond this realm? Yeah, I mean if it's infinite or eternal, or then that brings a whole nother facet into it. And obviously in the globe model, they say outer space is infinite, so they go on that
Right.
idea.
Yeah, and all I can experience is what I can experience, and I don't think we can go, outside of the reference frame or even up to where the stars are, if they're real or whatever they are. We can just experience, what we have here.
You
And
can't go there yet.
yeah, that's true. Never
But
know what's going to happen.
do you think the ground has to be rising up like that at an accelerated, like, you think that
It would
like is
it would have to be
required to account for things dropping?
in order to suffice like the laws of motion. Yes. Is there an instance like that everything like the only other way, in my opinion, that it would work is that everything is accelerating equally down together at 9.8 meters per second squared, which is like what Newtonian says that that's why you don't measure an acceleration in free fall is because everything is accelerating together. Like you said with jumping off a cliff, that is an interpretation of it, and that could be what's happening. But
Hey Jason, have
real
you ever heard
acceleration
that?
requires a force.
Have you ever heard that things go down for the same reason they go up?
Things go down for the same reason they go up.
It's the same mechanism.
What would that mechanism be? What do you mean?
That would be equilibrium.
Well, if something is accelerating, you have objects in free fall that appear to accelerate to the ground at a certain rate, and every state of matter follows this and follows exactly the same rate. So either everything is being affected by this force that knows exactly how much force to apply to every state of matter to make it accelerate the exact same amount, or the ground is accelerating up at 9.8 meters per second squared.
What if the ground is just where it is, and like, not to sound corny, but like water falls and fire flies by the same mechanism?
Well, yeah, I mean that's possible. It doesn't follow laws of motion that can be demonstrated.
Well, in terms of because obviously
Even
for
with
that
like
for the
no, go ahead. Sorry, Gio.
go ahead.
I was just going to say with there's an example of like buoyancy. Buoyancy, is seems to be only can be created by a force. The globe model, or I guess the Newtonian model says that buoyancy pushes up while gravity pushes down. But how can you have a force pushing in two different directions at the same time? If in the Earth rising up model, it would just everything's being forced up. The lesser dense items go up because they're being pushed by what's underneath them. The more dense items underneath them.
That's how it works in our model too, though. In our model, everything's being pulled down, including the things that are being displaced upward, like balloons. Those are just being displaced by other things that are being pulled down.
So there's a
pulled down.
force. There's a force pulling down, but also pushing up.
No, there's a force pulling down, and it's like if there was like a bunch of people heading somewhere, and some of those people are more important. They're going to push the less important people out of the way. Everyone's being compelled towards that place, but those other people are pushing the less important people out of the way. It's not, it's a single force that's doing that, though.
I got you. Yeah, it makes more sense to me that there's a force in one direction, and it's the more dense items are at the bottom, and they're pushing the less dense items up to the top. And that can be demonstrated in any other direction. What can't be demonstrated is a force in two opposite directions, other than begging the question of gravity. Unless you could show me something like that in another direction, where a force can push things two different directions.
Yeah, if anybody here could demonstrate what Jason just asked, I would be all ears.
What's that?
Hey, what's up, Skilly?
A single force causing something to go in two different directions?
Yeah, other than gravity.
Other than gravity.
Supposed gravity.
Gravity is one of the examples. So gravity causes buoyancy in one example. In another example, we can describe like that guy Smarter Every Day did in his car. He's driving in his car, I said he's got the same mechanism, the air in his car, and the balloon. The car is causing, or the acceleration of the car is causing the car to go one way, and the balloon and the air to go the other way.
Which is exactly what Jason is saying. That's
Yeah,
the opposite of what you were saying.
No, that's another mechanism of what's causing that. That's a
No,
singular
it's
force
motion.
in one
Wait,
direction
what's going
causing
what's
something in two
going
directions.
right? The car's accelerating one way. What's going the opposite of the car?
The balloon.
No, the balloon goes the same way as acceleration, like a helium balloon.
Yeah, helium balloon.
Yeah, it goes the same way as acceleration every
I
time.
meant when it's braking. When it's braking.
When it's braking, then it's decelerating, and then it would go
Yeah,
to
that's
the
right.
other direction.
But they're going in two different directions.
Well, it goes the same way as the force. Let me put it that way.
No, I think what it means is when the car accelerates, the balloon inside the car is moving forward, and when it decelerates or brakes, the balloon is moving backwards.
All right, it's doing the opposite.
Yeah, because then when it accelerates, the air in the car will be moved towards the back as the car is moving. Try to stay still, and the car moves forward, so you get higher density in the back.
Right. So that's acceleration in two different directions that's causing the different direction. It's not the acceleration in one direction causing the two different directions.
Yeah, but
The
it's the same.
acceleration, yeah, the acceleration is changing the distribution of air molecule inside the car.
Right.
So it's not, yeah.
Well,
And that's
Jason,
that's all that we're saying is what's happening in the atmosphere as well with the balloon. It's the same mechanism, just in a.
Wait, so everything is accelerating one way, but something else can be going the other direction?
Because that's what I'm saying. There's heavier air that's displacing the balloon. There's not the force isn't moving the balloon the other direction. It's just that the air is has more precedence than the balloon does. So it pushes the balloon. It's displacing the balloon. That's what's causing buoyancy.
buoyancy and density in comparison to what you would call gravity, and those how they all interact. The buoyant force can overcome gravity at times, even though gravity is still acting on it. You would say, or the buoyant effect.
I didn't hear that first part.
You know, I was just kind of restating your point, asking if that's what you meant, sort of. No, I was just saying. I'm just saying buoyancy and density, and like in the mainstream model, and how that contrasts with gravity, and how buoyancy and density interact. You know, they would claim that gravity is always acting on it, but then buoyancy and density can make alterations basically within what's already happening to the object from gravity.
Yeah, yeah. Well,
helium being like they would still claim gravity is acting on helium, but helium has a buoyant effect that allows it to contradict or kind of go against the gravitational force.
right, it's the density is what will determine it. So the density of the other air has more precedence than the helium, and so it's being displaced out of the way. Yeah, exactly.
Well, Jason, let me ask you this: like, okay, so obviously the mainstream model is gonna, they have the mass attracting mass and the bending warping space time and all of that. There's discussions and like the ether perspectives of like electrostatic force of which, but I don't know that anyone has really nailed that down to get to like the exact spectrum or what that might be. And then there's different ideas as well, like and then and then we're talking about like an upward moving Earth surface to account for this. But I guess what I want to ask you, like, if there was a force, let's just call it force X right now, like if there is one, whether it's let's just say for the moment that it is an electrostatic and it's just a yet undiscovered spectrum. Sort of like the sun has, ultraviolet and UV or UV and all the radio waves, all the different parts of the sun spectrum, visible, infrared, etc. Well, if the and I'm not trying to put this force as an entire theory or trying to like assert it. I'm just trying to use an example. So if there is, let's just say, a force X, and for the moment, just electrostatics is the way of something to put our minds on. But it's not fully understood or discovered yet. If that was the case, and that force X was acting on all matter, to cause the acceleration 9.8, would that, for you, shift you from the upward moving to, okay, it was force X going down to stationary, or are there other issues with stationary that even force X wouldn't solve? I guess that's kind of my question.
It would be a big, a big jump for me. Yeah, if something like that could be demonstrated.
Would it cancel out the requirement for an upward moving
Something
Earth
like what?
surface?
What would you like to be demonstrated? You got
Cancel. Yeah,
something
it
like
still
that.
seems like a big problem to me that that a force and acceleration will cause items to go in two different directions. A force in one direction causing displacement in two different directions. I need to think about it a little bit more, like what Kojo said, but it practically demonstrated. I haven't seen that, but yeah, as far as being able to duplicate, replicate, demonstrate that kind of force, if something was able to do that, then yeah, definitely it would hold a lot of weight.
Well, I
No
have a
pun
question.
intended.
So let's
Right.
also let's assume dielectricity is the reason things fall, right? So that's the reason all these things are falling. It's the reason the accelerometer is falling. How do you think it proved, like, how do you think it would, you think, so you don't think that's the case? So if that was the case, you think an accelerometer would do something different when it's dropped?
I don't understand what you just said. You cut out a little bit. Say it again.
Well, you guys bring up the accelerometer. I'm just wondering how like if your guys are claiming the upward Earth is making making things fall, and we're claiming dielectricity is making things fall, how would the accelerometer behave differently that you guys claim the accelerometer proves like the upward Earth?
Well, you would just have to demonstrate, electricity causing a force to equally accelerate everything down together.
No. That's
Well, that's the only way that it would change an accelerometer, or
I'm just
it would
asking you
equal an
how it would be,
accelerometer reading.
how the accelerometer would be different in each model.
I think he's saying it would be the same, and then
How would it
but you'd
act
have to
differently?
prove the force. Is that what
Right.
you're saying? Yeah.
Right. Exactly.
Yeah, no,
Well, you can
he's
manipulate
asking for
electrostatics to change something, right? But that doesn't prove
I
what the
wasn't
thing
asking.
is.
As far as I know,
I'm just
Jason,
asking
right now
how
you're a little bit delayed, Q up. Hold on, Jason. As far as I know, you're not right now claiming that the current observation of an accelerometer is exclusive to an upward motion Earth, right? Like you're not claiming that, meaning there could
No.
be something else, but you're just talking about all the physics and the components of
Yeah,
it.
in the physics that are known right now, that's without begging the question of gravity, that's the only way it works for me. Like, if you beg the question of a force that can equally accelerate all states of matter together, then yes, the only answer is the Earth upward accelerating. But if it can be demonstrated that a force can do that, or there is a force that can do that, then it's special pleading for me not to go with what can be demonstrated.
Doesn't the Van de Graaff generator kind of show that?
It just shows that you can manipulate a
everything.
force. It doesn't manipulate. It doesn't say what force you're manipulating. It doesn't say you're manipulating the force that makes everything accelerate down equally.
But it makes the things not accelerate down anymore.
You're changing the vector.
Go the opposite direction.
Yeah, but I could take a air blower and levitate a ping pong ball. I mean that's doing the same thing.
It's not doing the same thing.
I mean, you're just manipulating another force.
I see the overlap in what he's saying. I mean, air, one of them, he's saying blowing air, but the electrostatic one, you would have to agree, though, it's a little different because it's like, it's
Just
an
like they-
electrostatic field, though, versus like air. Like air to me seems more of a physical
You're literally
application.
changing the charge of you're literally changing its charge.
Okay, so then
I think
everything you're saying a specific charge makes everything go down equally, but if you manipulate a charge of one thing, then that one thing goes up and changes the vector of that one thing.
Wasn't it like the one guy said, equilibrium? Like everything's, so you change the charge and it's trying to find its equilibrium.
Equilibrium,
Once you
yeah.
change it. Yeah.
I mean that kind of makes sense to me, other than the fact that real acceleration requires force, and seeking equilibrium, does that mean that there's a force pushing it to the equilibrium? Because what we measure is an acceleration of objects in free fall towards the ground, whether that's up or down. That there is an acceleration there, and if it's a coordinate acceleration where the frame is just accelerating up, then the force is on the frame. If it's the item being accelerating down, then there's got to be a force that accelerates it.
Yeah, so if you're saying that you haven't seen well, of course, this is the whole question of what is gravity. I mean, even the mainstream will say we don't know. We
Right.
just have all these theories. So yeah, it's a huge question. It's not like this is some even thing that the mainstream claims that they have, even though they use gravity with their on the generalized scale with their kind of chest pumped out. I'm not talking about anyone in particular, but they go at it like because they need it for the globe model and all that. But if you're saying you don't know like a force that that force, but why would you then have any bias towards an upward motion Earth if you don't know what the source of the upward motion of the Earth is?
Well, it's just something that I couldn't reach anyway. Just like in the regulars, like a stationary flat Earth model, we don't know what the stars are. You don't know what's up there. I can't apply physics to things that I can't see, manipulate, and physically test myself. But what I can apply physics.
Because it's outside of the frame, you're considering it could be the case that you can't access it more than something that has never been shown to you in the frame you're in, basically, as a comparison.
Right.
But doesn't it still seem like a leap though? Because the force that would have to move the Earth up would be quite a
definitely.
thing.
You're definitely right.
It would have to.
But
it would have to be. It would have to be. It would have to be continuously accelerating because you would.
Yeah, we've been over
if
this.
It was going at one speed. You would just be able to jump in
right.
there. And
Nobody. Float. I didn't claim a constant speed.
Okay, so how? So what are we going? Infinite speed?
Maybe, I don't know. We're accelerating.
It can't be accelerating slowly either.
9.8 meters per second squared, bud.
It's not how.
I don't know if you were here. I asked him this. We talked about this. He was saying that essentially it could be going at really fast speeds, basically, like that it would just
right. If there's not something to relate the speed to, like in my interpretation of what's going on, is what I see is, and what I can measure is the force underneath my feet, and that force, a constant force will produce a constant acceleration. Period. Can be demonstrated 100,000 ways, and not a constant motion.
The whole Earth is moving at the same speed because it's all together. How do you
have like the whole system?
Yeah, how do you have different weights at different altitudes, which are correlated with? It's only like a couple correlations you can make with altitude, which is like the air or the charge in the air, which is the same thing.
Okay,
basically.
So so you're manipulating a different variable.
I'm not manipulating anything. I'm just at different altitudes, things weigh different.
At different altitudes, air pressure may be different. That's just that's a different variable that would cause things to be different. But does that mean that air pressure is what's causing the 9.8 meters per second squared?
No, there's an electric gradient, and as you move in it.
So this linear electric gradient of 100 volts per meter is causing acceleration of 9.8 meters per second squared?
It's no, the gradient itself is not causing it.
Oh, what's causing it?
We're living a vortex.
Oh, vortex is causing the acceleration?
Do you mind if I ask a question real quick?
Vortex is the geometry of the toroid.
Gotcha. Go ahead, Skilly.
You're saying it's like a vortex, like a screw, like when you screw a screw in, it pushing down into it. Are you saying that because a lot of even Isaac Newton, in his ether theories, and Tesla, there's these discussions that there's actually something coming down from above, like an actual motion of a shift. And so were you referring to that as vortices in the ether that are pushing down because they're vortexing downwards and causing things to drop? I just wondered if that's what you meant.
Yeah, we're above the inertial plane, and everything's being pulled down by magnetism, and then dielectricity, which is the same thing.
All right, someone else was jumping in. Go ahead.
Skilly, was that you?
Yeah, I was just gonna ask you up if there's different weights in vacuums. Does something's weight change in a vacuum?
I don't think so, but I'd have to check. I don't know.
Does anybody here know?
Apparently, they fall same rate.
Yeah,
All
fall the
fall
same rate, but
I'm talking about
there's
weighing.
no there's no buoyancy, so actually things weigh more in a vacuum, at least at sea level or whatever.
And that's
Yeah,
the impression.
The only real difference is the
That's the
buoyancy
impression that
force.
I was under. So like a gradient would, in my opinion, change that a bit.
I agree.
Yeah, if you eliminated the air and then you still manipulated the electrostatic field, it would levitate. And I don't know if anyone's done a Van de Graaff generator in a vacuum, though.
I have a Van de Graaff generator and a vacuum.
Just put
Wait,
them
has
together.
that been done? Has that been done?
No, it should be, though. I don't know.
The thing that's so interesting about the Van de Graaff is that it's basically pulling the static electricity right out of the environment. So the fact that you can change like the vector of an object with something that you're pulling right out of the medium itself, I think is pretty cool. Doesn't mean that it's like 100% proof that that's what gravity is, but it definitely seems like it's if nothing else, it's overlapping in the spectrum of what we call gravity. But yeah, doing it in a vacuum chamber. Does anyone know if that's ever been done? I've never really heard of that. Van de Graaff in a vacuum chamber?
Van de Graaffs are mostly toys that are like, people's hair going out like crazy. Since you can't have a person in a vacuum chamber with their hair sticking out, they probably don't bother, but probably could be. I don't know. Good question.
You can make
if you guys
star.
know,
Yeah, GPT says they have.
Hey,
you
want
to
know
in a vacuum, like a light
I imagine it's
vacuum.
been done. Yeah, I imagine. Yeah. I mean, I just don't know that I've seen like the reference to it, or if I've seen it. But so if you find any links to it, it'd be interesting. Do you guys know that Tapioca in the I think it's still on the server, but he's in this community that he's actually Van de Graaff's grandson. And that's not doxing
cool.
him. It's not doxing him. He's said that many times on the live stream. It's actually his grandfather, or either grandfather or great grandfather. I think it might just be his straight grandfather, but yeah.
Hey, you know what is cool about a Van de Graaff generator that I've seen?
That was crazy because I was there when he said that. Actually, Gio, that's crazy.
Sorry, I was just going to say real quick. With the electrostatics or electromagnetism, if you do get something to levitate with electromagnetism, I'm assuming electrostatics or a Van de Graaff generator would do the same. Is whenever you levitate something with the Van de Graaff generator, if you were to put a scale underneath the Van de Graaff generator and see if the weight changes whenever it's levitated of the whole thing. Because if you are manipulating gravity,
ridiculous.
Well, why would you want to manipulate? You could just manipulate light in a vacuum with magnets and like kind of get a similar type of a radiation effect of what gravity kind of does modeled.
Wait, Jason, what did you mean? You mean put a weight under the actual Van de Graaff generator itself?
A scale to measure weight. Well, because if you're saying you're manipulating weight of items with the Van de Graaff generator, changing the charge, Action Labs actually did this cool deal where he did with magnetism with the big magnets and the quantum locking deals where you levitate it with the frozen disc or whatever and put a scale under it and the weight did not change at all because he's just basically putting a. I'm sorry. Go ahead.
Let's not interrupt, bro. Why are you flipping him? He was almost done.
Yeah, I was just saying that if you are manipulating the weight of something and changing the charge of it to where it weighs less or levitates, that the actual weight would be less. But it's just building a bridge in between the magnet, building like the pressure gradient around it, causing it to levitate. I'm assuming the Van de Graaff generator would do the same. I have not done that test.
Yeah, so it's like things just
Go ahead, Q.
Things just flow. Things just flow. They don't stay like you're. It's not a possible like thing you can do because the thing's not going to stay above the Van de Graaff generator. It's going to float away basically. So obviously, if you could weigh that difference, it would weigh less.
Okay. Well, I'm
It's
just
not
saying
gonna
with
be-
electromagnetism, it doesn't weigh less. With something levitating
In
above an electromagnet. Action Labs did a video on it. It's pretty cool. I can
Wait, but
link it when I find it.
I'm still
Yeah,
trying to
there's
fully
a-
understand what you're saying. So a Van de Graaff generator is like a belt essentially, and it uses
Wait,
static
we already
electricity.
we've had this agreed before.
So it spins it up. It spins it up like a belt, basically creates friction, and then it uses that when you then connect it to two metal plates. You connect
Right.
it, and then it creates
It
that static
flips
differential.
polarity, I guess.
Yeah, so like one idea is like when that little piece of paper that's down on the bottom plate, you fire it up and now it goes up to the top plate. There's been one idea of does that measure a weight, going up? Like if you were to flip a scale upside down. So there's
Right,
that
I got
question,
you.
which I thought that's what you might have been referring to, which is an interesting thing. But you were actually talking about putting the whole Van de Graaff, that's spinning on a scale. And then, but what would be the idea of that? That if it changes the weight of it changes the little sheet of paper between the plates, that also maybe the weight of the actual whole Van de Graaff that's spinning changes?
Or just like in between the plates, or whatever you're changing the charge or manipulating the charge of, and making it levitate. That it would.
Oh, so you are talking about that. You are talking about putting scales on. Okay, that's what I thought. But for a minute, I thought
So
you
he's
meant
like-
putting the actual Van de Graaff on a scale, and I was
No,
like, okay,
I apologize.
okay.
Not what's generating the charge. What's being manipulated.
But that's still kind of interesting too,
Yeah,
actually, if it did change by putting it. I mean, that's
how would you do
test
that?
both.
That's ridiculous. So I've told you the thing. We've already gone through this, like with the, magnetic locking, like little toys. They're literally locked, so it's not. Why would it?
Oh, you may be talking about Ken. I don't think I've spoke to you about that, but that was actually Ken's idea. He's in the chat
It's a
too.
bad idea, and I explained it's not. It's
I'd
not
like to jump in too if I could get a
anonymous
second.
at all.
Yeah, go ahead.
I heard QOP claim constant speed. He accepted it as an inertial state earlier. Do you accept that, QOP? That a constant speed, if Earth was going at a constant speed, you could just jump away and float away. You accepted inertia there a while back?
Accepted inertia?
Yes, you said if Earth was going at a constant speed, you could jump up and float away. The first law of
You wouldn't
motion.
float away, but
inertia.
you would just float, I think.
So you agree, if Earth was in an inertial state, you could just jump away, right? If it was going at a constant speed, you could just jump away.
Okay, yeah.
Stationary is also an inertial state.
But it's not. We're not
And
claiming that there's
not
no
only
force.
that, but
I mean, there's
your
a force.
electric gravity theory claims a inertial plane. So not only are you that we're walking on an inertial plane. So not only are you claiming acceleration without displacement, you're claiming an inertial plane with unbalanced forces when inertia is no unbalanced forces.
Which is why salad, brother. You just took different definitions and
you
names
accepted
and
inertia.
Yeah, but
So
inertial plane has nothing to do with the kind of inertia.
Yes, the electric model claims an inertial plane.
QF, do you know what inertia means? That might be the.
Oh my god, dude!
If you understand constant speed as inertia, why don't you understand stationary is also inertia? And inertia means no unbalanced forces, which is why you could jump away, which is why your coffee is the same at a constant speed in your car or stationary in your car. Agreed? Do you understand inertia at all? Because you're claiming electric gravity, and electric gravity claims an inertial plane. So if you don't understand inertia at all, maybe you shouldn't even be in the conversation.
Where'd you get your definition for inertia? Can you
First law of motion. First law of motion.
Can you cite it in the chat?
Isaac Newton.
I'm also trying to understand,
so those are all targeted towards me. So when you're talking about like inertia and momentum, you're talking about basically motion through like a vacuum. So
You do realize your electric theory calls for an inertial plane. If you can't
I know, but that's
describe
just the name.
inertia,
That's just the name of it, dude. We're not. So it's
That's
not
just a
has
word.
nothing to do with
It's just a
the
word.
inertia.
When you accuse me of word salad and you're using a word in your theory
How
that you
could I
don't know
even make
that you
word
can't
salad if I didn't
describe.
even make a sentence yet?
All right, well, hold up. Let's just. How about you two go back and forth, and like no one else jump in. Just let you, if you guys want to, for a minute. I'm not trying to call you guys out. I'm just saying that way, like no one else jump in, and then just try not to interrupt each other because I'd like to hear. I think we'd all like to hear the back and forth. So just let each other, as long as you don't monologue, just let each other go back and forth, and just don't clip. So then you guys can say your points. I think did Q up? Did you get someone interrupted? Just finish your point.
Yeah, I didn't. I'm gonna forget my fucking. Um, so you're comparing. You're basically pigeonholing the dielectric like force argument just because into like some inertial like having to like um grant like your argument with inertia just because of there's a part of the ether field that has like a name called the inertial field. It's basically
So
all you're
you're
doing because the problem you guys have the problem of needing to be constantly accelerating because at like at a constant speed your inertia is going to cause it so that people are just basically weightless. So there's no problem with the stationary Earth, which just has a continuous uh, same speed force, like the same force going down. There's no you're not floating through a vacuum. You're not flying through a vacuum. There's no motion of the Earth.
okay. Back to your claim of an electric gravity. You do know your model calls for a inertial plane.
Oh my God!
So you have a model, you don't know what inertial is.
It's just it's just talking about the part
Why
of
are
the toroid.
you backing a model that calls for us to be walking on an inertial
Right.
plane and you don't know what inertia is?
Bro, it's not talking about
Let alone you can't
that inertial
demonstrate
plane
that.
is not moving. It's just
Let
the
alone you can't
part.
demonstrate.
It's just called that, dude. It's just your
Explain that.
definition.
So we're agreeing. You are the word salad guy.
Wait, what's the
Explain
issue
No,
with
you're
inertia.
not. We're
And I
what's the
have the
issue with
laws
the
of motion
inertial?
on my side.
Wait, what's the issue with the inertial plane? If it's a stationary at rest plane to have your foundation, what's the contention with that?
It's the
Inertia
name.
means
The name is making him think that it's like moving.
Yeah,
what?
explain inertial.
It's
Yeah, I
just a
think
part
he's
of the
talking like
toroid
he
where
doesn't know what
in
inertia is.
between it's sliced through the vortex, sliced through the apple. That's what's called the inertial plane.
Where
You have
there's
so many.
no inertia? No inertia there.
There's no inertia, but it's talking really about the inertia of like the dielectricity going through that area. It's just a name. It
Yeah, that's where, well,
has nothing to do with what he thinks it is.
right. The plane is
The word is
representing
a definition.
inertial, not the inertia plane. Inertial.
So
I mean, doesn't the word
It's
inert
basically
mean
it's really
like,
just a name, dude.
doesn't it come from
yep.
the word inert? And so an inertial plane would imply that there's like no motion or that it's something to that effect.
No
I don't know.
unbalanced forces. No unbalanced forces.
I don't think so.
Stationary or constant speed, exactly the same.
Yeah.
When there's unbalanced forces, there's an actual force, and then you
What's
have
an
displacement.
unbalanced force? What does that
Anything
mean?
that pushes, if anything that accelerates something. If I accelerate any container, any accelerometer, it's going to register acceleration. So QUp is not only claiming that he can accelerate things without displacement, without demonstrating that, he also doesn't understand the inertial plane he's claiming for his electric gravity.
So I had to look
So,
this up
so
because
QUp can
you don't
neither
believe when
steel man electric gravity, nor can he steel man the laws of motion and upward acceleration Earth.
before I mean for you to steelman these my model, you have to understand the term you keep using, inertial plane, has nothing
He
to
probably
do
shouldn't have ran
with
around
inertia.
running his mouth
The
so
way you're
much.
thinking. I just looked it up for you. An inertial plane is a geometric surface or physical object. Is not accelerating or part of an inertial reference frame. It's just a name that's you're getting caught up on a
Something
name,
you made
bro.
up just from word
That's
salad.
not doesn't
You
mean
just
anything,
use the
dude.
word inertia, but there's no inertia.
I mean,
No, there
it's
is
It's just
a
a
inertia.
name. So
separate
you know how like
definition.
sometimes like we say like you're gay and don't mean you're gay. It's like that.
Well, there's just
No, no,
different
no.
usages
So
of the term within different physics systems. Like relativity
exactly.
is going to have their own. Yeah.
Both ends, your claims go completely against the laws of motion and all demonstrable reality. It's can we agree on that? You can't demonstrate anything, any of the
So,
claims.
what's your definition of inertial plane, Ken?
If there was an inertial plane, there would be no unbalanced forces. So any force I added, you would accelerate away.
Okay.
Right.
Wait, say that again.
Like in the vomit comet, that's an inertial state inside there. So if you jump away from the wall, you're going to continue in your same vector.
If there was an
yeah, you're referring to reference frames now. Yeah, you're kind of
the difference between inertia and
yeah, and you're talking about like inertia within reference frames. I mean, dude, if I'm not speaking for Q. If he's talking about like a dielectric stationary inertial plane, there you could say that there's just like a universal reference frame, and then there's a stationary plane in that universal reference frame, and then you would have an electrostatic effect in which things are falling towards that plane. So it's a universal reference frame. I think what you're referring to is you're getting into like using inertia within the definitions of specific reference frames. Like for example, if you're in a car and you accelerate and you push to the back of the car, you push up against the seat as you accelerate really fast. It's because your body wants to stay inert, and then so that's a form of acceleration and the inertia and so on. So I think you're linking some of those factors to the word inertial when it comes to the word inertial just meaning at rest with no motion.
Yeah.
And yeah, nothing's acting on the plane, but there is something acting on objects falling down to the plane.
Yeah, and that's why I said we're not. It's just a straw man, basically.
Yeah, I'm not trying to assert all that. I'm just kind of trying to clarify. I think what QOP meant, and he can correct if I'm wrong. But
yeah, it seems like you guys are talking past each other a little bit.
Inert just means lacking the ability to move, and when you're floating when you're moving and floating through an inert when you have inertia through a reference frame, then if you don't have the ability to move, you're just kind of staying with that inertia. But we're not talking about laws of motion. We're just talking about inertial plane, which is a magnetic field term in this situation.
You can't hand wave the laws of motion.
But we're not talking about the laws of motion with the magnetic field.
You can't hand wave the laws
It's
of
just
motion.
called inertial. It just
they're not laws. It's
they
a description of most of it, but nothing is a law with thermodynamics or motion.
Things don't move without a force. Things don't stop moving without a force. Can you demonstrate otherwise?
No, I get it. I mean, I get it.
That's why inertia is a constant.
But if you're not talking about all the forces, then no one's winning.
And when things are moved with a force,
Yeah, that's
they
why it's
register on an
balanced.
accelerometer.
It's balanced because it's equalized. The equation is solved when you balance an equation, right? So things are equal because there's a balance of up and down. But it's the same mechanism over a plane.
Plane.
And a plane is just like the equal sign. If you're ever doing a math equation, that is the equilibrium mechanism in and of itself.
Convergence to divergence plane there.
Well, it's like pressure and resistance. Like if I'm pressing on something, that same thing is actually resisting the same amount of pressure I'm applying.
Everything
until
is
it
CQ
finds
rest.
equilibrium.
So you guys are denying the laws of motion. Do you have any demonstration of them being broken?
I mean, I just used to ride my bicycle, and jump it and stuff, and I drove cars.
That doesn't make any sense.
Well, I mean, you can do the equations too, but you can also you can describe it with the forces pushing back.
Why would
but we use the math equation
without a force?
The math equation. The reason why it's
The
equal is because
the answer really is no. You can't demonstrate the laws of motion being broken, right? Especially not QOP, who can't demonstrate any of his own claims, let alone demonstrate breaking the laws of motion.
You got a bone to pick.
Oh, he's been running his mouth all over the place, taking off, going to every internet, every YouTube chat I go.
If I tell people I'm a flat earther and they find out that flat earthers think
hey,
the
Q-Op, I'm
earth is
trying to say
rolling,
something here.
I'm going to cry.
One of the things he said is he's not going to let upwards talk in Earth Awakenings. Would you like to see a copy of that?
I didn't mean it like I won't. I
Oh,
meant
you
like
didn't
I'm
mean
gonna
it
shut
like
it
you
down.
said it. You didn't mean
My
it like
God,
you
you're
said
like
it.
treating it like a
We've
religion.
been
You're
going
like
to different chats,
he
talking shit about me and upwards, and then running
Bro,
away and
every
not
time I
facing
go,
me.
every
I
time I
also
check the live
defeated
chat,
him in
you guys
debate
are
on his
talking
own
shit about me.
channel. So yeah, I got a bit of a bone to pick with him, which is over now because I destroyed him.
Destroyed.
He can't steel man his own model. He can't steel man the laws of motion. He doesn't belong in the debate.
We're not
I'm not
talking about
saying the
laws of
law.
motion. We're talking about
It's over for
dielectric
him.
flow.
The
Unless
laws.
anybody,
Electricity doesn't
I mean,
care
if
about
you guys
your
think a guy
laws
should
of
just
motion.
fantasize and stuff and just say, it's all electric, guys. It's all electric. Why don't you guys know everything's all electric? That's all he's got.
Well, it's because it isn't really explained. With the laws work.
If you find that valid debating, I don't.
All right, but don't you? Okay, so but you were talking about the inertia. So if QOP is putting forth an inertial plane, and then a electrostatic or dielectric force that is that what you would call it, QOP? Trying to figure out your like Steelman to some degree. But if he's claiming that that's involved in why things fall, then why not address that part of it directly, Ken? If that's what you were going to refer to, because you were talking about like the inertial plane part, but I mean that, like I was saying, if you have a universal reference frame and a stationary plane, then you go from there,
Any stationary Earth model is going to be an inertial plane. Any stationary flat Earth model is going to be an inertial plane. And
how
like
are
I
we not?
pointed out,
How is it not following the laws of motion?
stationary and a constant speed is exactly the same. And you guys agree that if Earth was going up at a constant speed, that couldn't possibly happen because if you jumped up, you'd just float away.
Strawman.
Well, the same thing goes on with stationary because, like I explained about the no unbalanced forces, meaning no forces at all, or the forces are in balance. If things are pushing down more, how can the forces be in balance?
This is
How can
all
things
this is
be?
all based on the fact that it's called an
Not to
inertial
mention,
plane.
he cannot demonstrate acceleration without displacement. He can't demonstrate accelerating an accelerometer without an accelerometer registering it.
All right,
Nobody
well
can.
let's let him respond and let's not clip him or interrupt him. Just say his full. It's all good. Let's let him say his full point.
I don't want to go back and forth, dude. Someone else do.
Well, I was trying to preface so you wouldn't get interrupted, so you could respond.
QOP, defend yourself. QOP, what the heck?
He's
I'm working
quitting
for you
every
here.
time he's facing upward, or
It's
every
not about
time
defending
somebody
myself.
kicks us out.
To keep explaining that inertial plane doesn't mean what you think it means.
No, it didn't mean what you thought it meant. That's why you dismissed the term completely. And then you got educated what the term meant. Now you're saying, well, whatever,
Okay,
it doesn't matter.
now I have to explain that to Synclaser.
That's what happened,
they're
QOP. Come on,
misunderstanding.
just now you know though, right?
Yes, thank you, you guys educated me. Thank you. The magnetic field, because
You
it's
didn't
called
pay a
inertial plane
dime
in the middle,
for it.
means
You're
it's moving.
welcome.
Thank you. We're moving. We're all moving. We have to be moving because it's called an inertial plane, and that's what Ken thinks.
Or we're not moving at all, and it's still balanced.
No. We're moving.
Dude, QOP, do you think that I don't know if are you going to respond to him or should we?
He didn't have to respond. No reply required. Moving on, maybe.
Well, I was going to kind of ask you up then. Like, how do you think the electrostatics correlates with buoyancy and density? How do you think that how that factor plays in?
Everything is everything is a different every different type of molecule, every different type of density. Everything is just a different type of charge, basically.
Magnet.
So literally, it's all mainly going down because there's a giant ether flow. We got a giant vortex going on, but there are little toroids everywhere. You can see toroids in apples, sunflowers. You can see atomic structure seems to be vortexual.
We're on top.
Sorry, what?
Saying we're on top, so the equilibrium of down. I didn't mean to interrupt. I kind of agree with you. I mean, it's hard to explain, but anyway.
But I guess what I was like, how does like density play into the electrostatics? Like, are the electrostatics higher if something's more dense or lesser?
Well, like with with like temperature, right? Temperature is just a quicker vibration of the atoms or molecules. Um, and then density is like so things get denser when they're like moving less, I believe, right? Like when they're packed tighter, they're probably moving less.
Right.
So that's still just another, that's just a different charge. So it's just charged in a different way.
So
Getting them to be
Q up.
compact.
So if you had a density tower, like was posted earlier, could you use electrostatics to reorientate that in any other direction without using motion? That's the question. Can that be demonstrated? It's
You
very
mean flip
simple.
the whole density tower?
In any other orientation, any other vector, reorientate that entire thing without using motion.
Yeah, but not. I mean, hypothetically, like with secret, like kind of ether tech, but not a Van de Graaff generator, obviously. That have
I'm
to be
sorry,
like some high level shit, like some
I didn't
UFO
catch that.
shit.
What did you just say?
Have to be like government like shit, like secret stuff.
The reason I ask is because using motion, you can reorientate that density tower in any direction, 360 degrees, and it will reorientate. It's crazy. It's very simple.
Yeah, I mean, what there's it's just hard to get like that much charge differential from just like basic like personal equipment.
Well, what
Well,
does
why do you say it's just charge and not orientation based on the reference frame of up and down?
what does motion do though? Charge.
Like you'll have to explain the mechanism if you can't. And it's not only charge because charge is an energetic, you know.
Yeah, I don't want
So
to talk
like,
to
what's the
Sim.
mechanism
Just
for
says
why
like
charge
sentences
goes
that
a
don't even
direction?
fucking.
But do you see how silly it is to say that how stupid like the upwards vector is? When everyone who's talking about it can easily demonstrate it, and you cannot. In any other vector, you cannot demonstrate it. But yet you will actively fight against it. It's literally no different than a glober.
It's just easier to just shake something up than to charge it enough to make everything flip. So it's just.
I don't know
Well,
if
when you
this is
shake,
going over your head or not, but
when
it
you shake
sounds
it,
like this.
yeah,
It's not.
when you shake it,
I just
you
don't
add
think you
energy to
understand
the
like how
system,
much, what kind of
and
equipment
you
you would
take
need
it
to
out
do
of
that.
equilibrium.
It's not something you can buy and just I've got a Van de Graaff generator, but I can move like little things, and you want me to change the density tower of what liquids?
What we witness in this reality, these density layers, and we have a vector. We have a vertical and a horizontal. We can tell by the way water's orientated, right? Water is the key and always has been from the beginning. The reason, real quick, the reason most people became flat earthers, quote unquote, was because of water. That was the main proof because water is level.
So it wouldn't surprise me if you did.
He did. I'm gonna post it here. I'll post it in the live stream right here. I just
Yeah,
like
all kinds
literally.
of dumb
So I
things.
have
He's
this
not
idea. Let me say this
I don't know
idea.
how anyone can listen to that guy.
Yeah. So someone just brought up something interesting, right? If the Earth is rising, like why is there the change in the rate of fall as you gain altitude? And I'm picturing this like, okay, so you have like a less dense layer of air at higher altitude. And if it's moving slower, like the initial, like it goes from being stationary, right, in your hand, and then you let go. The resistance of the air is going to affect how much it's accelerating, right? And then as it falls, it's that resistance is going to decrease. I'm just trying to
Yeah,
picture
but you
like
can
if
do
it
this
were
test.
to work, if there
There's
was a way to fix
gravimeters that work by measuring an object falling in a vacuum tube, and that's not
yeah,
going to
no,
be
Earth is a
affected by
ball,
that.
right? Yeah, okay.
No, I mean those are
You don't have to
built.
just wave it away. I mean, I'm just stating you a fact.
That's how some gravimeters
She wasn't
work.
talking about a vacuum, though. She's talking about on Earth. To be specific.
Yeah, but it's
right. But
this guy's explanation
that's the point of the experiment. Is you use the vacuum to get rid of the air, and so you show that whatever's falling is you increase in elevation. There's a change, and you take air out of the equation with the vacuum.
Yeah, I understand. It's just, you want to get like a mountain high fucking vacuum. Where's that?
I think it's been done. They just bring a vacuum up. I don't know. That's what I assumed, I guess.
I had a bad
Those things that
reception,
designed
but
to do this, very precise.
can you hear me again?
Now we can, yeah.
Okay, sorry. So regarding the long vacuum, the Bremen drop tower, for example, has something like 100 and something meters and can be fully evacuated. But I think I was breaking up, and I don't know how much you heard regarding the weight difference in height.
Oh, we didn't hear anything.
Okay, so that basic experiment was a balance scale. So it was done in the 1800s or so, after Cavendish, but it had basically two weights on the left and on the right side of the scale, and it was completely in balance. Was a very accurate scale, and if the right side test weight was lowered by a string closer to the ground, so the scale was something in 20 meters height or so, and then the test mass on the right side was lowered to the ground, and it gained weight, so it got heavier. And once it was pulled up again to the top of the tower, it was in balance again. And there was a second experiment. They lowered the right's test weight to the ground or closer to the ground, and then they rebalanced the scale. So they added some weight on the left side so that it was in balance again. And then Philip Dioli pushed a big lead ball, so 1 meter in diameter, below that right test weight that was lower to the ground. So increased basically the mass closer to that test mass, and it gained again some more weight.
So
And I would like to hear your thoughts again.
What was their conclusion?
Okay, back in the days, that was that experiment kind of confirmed Cavendish's idea of Newton mass attracting mass, and they could also, with this, they could measure, or they claimed to measure, the actual weight of the Earth, because when they know, like, this lead ball test mass increased the weight by a certain amount, then they could also measure this 20 meters closer distance, increase the mass by a certain amount, so they claim to know what the Earth weighed afterwards. But I would like to have your thoughts on this phenomenon, if it would be right. And because the point is, the density at the ground is higher of the air than at the top of the tower. So if it would be just buoyancy, there would be more buoyancy at the ground, but still the test mass was heavier at the ground. So any thoughts?
So a little lead ball is making an effect over the mass of the Earth if they're thinking it's gravity.
It would be increasing the attraction from the Earth. So,
but the lead ball is so much smaller than the Earth. How can it have any effect on the gravitational pull?
But it was way closer to the test mass. So like the test mass is 1.5 meters from the ground, but then you push the lead ball there, which is then only a 0.5 meter distance. So it increased a little bit again on that weight, they said. Compared to the other test mass that was 20 meters away. So like in the top of the mountain. So that was the important thing. Like if you decrease the distance to the mass, the attraction gets bigger, kind of.
Oh man.
I feel like you're making an assumption, thinking that's gravity, but that's just my gut.
I have no idea.
I
seems
just
like
at the moment I just described the experiment and the things they found there. So I don't want to make any assumption. I just want to have your thoughts on
No,
these.
I'm not talking about. You said their conclusion was it was proving gravity. I'm not talking about your
yeah.
claim. So
Yeah,
to me, my gut's like, yeah, that it could be another phenomenon. You're manipulating that variable so minusculely because the variable is Earth, right? So it could easily be a different phenomenon going on. I guess is
yeah.
my gut reaction.
The one variable is definitely the distance to Earth. So they changed the variable of the one side of the scale to decrease the distance, and that made a difference. And the other variable is like increasing kind of mass closer to something.
Distance would seem to like point toward some sort of electrical phenomenon. You're creating a shorter distance between the two. Weak electric forces, can't happen over long distances. So the closer you get them, the stronger the effect of the electrical. Like that's my hunch right off the bat, but it's interesting.
That would explain something, yeah.
Because like in the Van de Graaff generator, I looked it up in 1933. MIT put a Van de Graaff generator in a vacuum. I was just reading ChatGPT, and it still has the same effect as the Van de Graaff generator. It still can levitate things, but it's much weaker. So air plays a part in amplifying that party trick, that levitation effect.
Yeah, because the air can also be charged, vacuum not.
Yeah.